Welcome, stargazers. Could you, at any point, accept it? Picture a divine occasion so enormous that it creates shaded areas on Earth, apparent even to everyone, so they can see. That is the display we may be near, the precarious edge of seeing in the Orion group of stars, the star Betelgeuse. It is acting bafflingly, alluding to a looming cosmic explosion that won't illuminate our sky like ever before. Yet when will Betelgeuse go supernova, and what will it resemble, as per researchers? What secrets could this heavenly occasion disclose? Join us as we jump deep into the subtleties of what's actually the deal with Betelgeuse and the effect it could have on Earth and maybe for the whole planetary system. Found roughly 650 light-years from Earth in the star grouping Orion, Betelgeuse isn't just any normal star, it's a red supergiant, one of the most iridescent stars known to us, sparkling with a brilliance over 100,000 times that of our Sun. Yet, why does this red giant matter so much to us? Well, Betelgeuse stands out for its splendor as well as for its history and importance in human culture. Named after the Arabic expression Yad al-Ziwith Makron, which means the hand of Orion, Betelgeuse has been noticed and recorded by ancient civilizations for quite a long time. It has been a guide for voyagers and a place of wonder for stargazers, with its rosy tint distinguishing it from other stars in the Orion group. Can you imagine a single star overshadowing our whole planetary system? To give some perspective on the sheer enormity of Betelgeuse, if it replaced our Sun, its edges would stretch all the way to Jupiter. How could a single star achieve such epic extents? At 10 million years of age, it's significantly more youthful than our 5 billion-year-old Sun. However, Betelgeuse's gigantic size means it consumes its materials at a much quicker speed, predicting a more limited life expectancy than that of other stars. Now, the divine behemoth, crossing a volume large enough to contain more than 1 billion of our suns, is approaching the end of its life cycle. When stars of such greatness reach their twilight years, they don't simply disappear. They make a dramatic exit, a supernova explosion that is beyond human comprehension in terms of its energy and splendor. Such an event has the potential to eclipse a whole world, creating shaded areas of brightness across vast distances. The last time Earth saw a supernova this nearby was in 1964, well before the advent of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way system with the unaided eye, remaining apparent for more than 1.5 years. It was brighter than any other star in the night sky and even remained visible during the day for months. What secrets do these heavenly remnants uncover for us? Ancient records from various civilizations, including Chinese and European astronomers, reported the presence of this new star. Interestingly, remnants of this blast, as an expanding debris cloud, can still be observed today with advanced telescopes, providing us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine for a moment a stellar explosion so extraordinary that it rivals the brightness of a full moon, creating shadows on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially affecting satellite operations and, perhaps, even the environment. Betelgeuse, with its erratic dimming patterns, suggests it may be preparing for a particularly grand display. Might we be on the verge of witnessing one of the universe's most dramatic events? Recently, space experts made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent an extraordinary change that drew the attention of astronomers and enthusiasts alike, known as the Great Dimming. The star's brilliance, which had been stable for decades, began to diminish significantly. This unexpected change was so evident that even casual stargazers noticed it when comparing Betelgeuse to other stars in the Orion constellation. This implies that we're not only hundreds of years from seeing its supernova, but maybe just a few decades, or even less. By April 2023, astronomical observations reported that Betelgeuse had returned to its normal luminosity levels, leading many to think that the time of oddity had ended. In an astonishing turn, the following months saw Betelgeuse's brightness increasing by an astounding half. Such significant fluctuations, while common among variable stars, were rare for a star like Betelgeuse, which had predominantly exhibited predictable luminosity cycles. The abrupt and intense surge in its brightness pushed the star back into the spotlight, igniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, perhaps the most recognizable star in our night sky, suddenly throw a cosmic curveball? Stars are not just twinkling dots in our night sky. They are dynamic entities with life cycles, activities, and secrets of their own. For most celestial bodies, periodic brightness variations can be expected, much like the rhythms of Earth's seasons. Throughout its celestial lifetime, Betelgeuse has maintained a fairly consistent 400-day luminosity cycle. However, with the Great Dimming, it seemed to defy its established behavior, testing our understanding of the cosmic phenomena above. Now, you may be wondering, are we on the brink of a celestial revelation? While the specific reasons behind Betelgeuse's anomalies are still being scrutinized, a compelling hypothesis has emerged. This theory, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a titanic cosmic volcano subtly ejecting and expelling a tremendous amount of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled a vast amount of its surface material into the universe. This ejection, a spectacular event, was 400 billion times the mass typically released. During similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a dense dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust dispersed or was driven away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal brightness levels. One way or another, these new occurrences suggest a star that is not finished surprising us. Many speculate that Betelgeuse may be approaching the twilight of its life, a supernova event, a stunning eruption of energy that can overshadow an entire world instantaneously. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star or, in Betelgeuse's case, it may be due to the depletion of its nuclear fuel, which compresses its core, paving the way for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse initiate their process by fusing hydrogen in their cores. This initial stage, known as the main sequence phase, lasts for millions of years and forms the foundation of a star's life. When a star runs low on hydrogen, it evolves, adopting new energy sources. In the case of Betelgeuse, as hydrogen depletes, it begins to fuse helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium-burning stage is marked by the star's evolution into a red giant. Over time, as helium continues to diminish, the star undergoes further expansion and transitions into other burning stages, each characterized by the fusion of progressively heavier elements. The larger the star, the faster these changes occur, given the immense gravitational pressures at play. Then comes the climax when iron begins forming in the core. Unlike lighter elements, iron does not produce energy when fused, so the energy generated is insufficient to counteract the star's own crushing gravity. The star inflates in size and undergoes a collapse, followed by a massive rebound explosion, resulting in the violent force of a supernova. So, is Betelgeuse on the brink of a catastrophic end, or is it biding its time? Recent research by Japan's Tohoku University suggests that the star may currently be in its helium-burning stage. Lead researcher Haddock believes that the core could implode a few decades after its carbon reserves are depleted. However, not all scientists agree, with contrasting studies from Hungary's Konkoly Observatory hypothesizing that Betelgeuse is still in the earlier helium-burning stage. The one thing that researchers do agree on, regardless of these discussions, is that Betelgeuse is set to become the Milky Way's next supernova. Yet, pinpointing the timing of this event remains a cosmic guessing game, with estimates ranging from just a few years to 100,000 years. Amid these scientific debates and speculations about Betelgeuse's fate, one truth remains unchallenged. the very nature of our observations. When we gaze toward the brilliant cosmos, there's a subtle paradox we often overlook. This curiosity is rooted in the fundamental nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes time to reach our eyes. For example, the speed of light, while an astonishing 186,282 miles per second, still has its limits. Consequently, the light from distant stars and galaxies takes its time to navigate the vastness of space before it graces our sight. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this light set out on its journey toward Earth, the Renaissance was unfolding, and travelers like Marco Polo were exploring new lands. This means that by the time we observe Betelgeuse's eventual supernova, the event may have already occurred long ago in cosmic terms. We are essentially looking back in time, witnessing the legacy of a star that has existed in its current state for centuries, even as its future remains uncertain. As we wait for this magnificent event, the excitement grows among astronomers and stargazers alike. The potential for such a bright, dramatic display in our night sky is not just a scientific curiosity, but also a reminder of the dynamic and ever-changing nature of the universe. Whether it's through advanced telescopes or the naked eye, Betelgeuse's story continues to captivate our imagination, urging us to ponder our place in the cosmos. In conclusion, Betelgeuse stands as a testament to the mysteries of the universe, a symbol of both the beauty and unpredictability of stellar life cycles. As we gaze upward, let us remain vigilant and curious, ready to witness what may very well be one of the most significant cosmic events in our lifetimes. The journey of understanding Betelgeuse not only enriches our knowledge of the stars, but also deepens our appreciation for the vast, interconnected tapestry of the universe we inhabit.